of elements and periodicity in properties of the elements. So in this class, we will know about the elements of the periodic tables, how they have they classified in this periodic table. So in this course, I will talk about first of all why the classification is needed of this element. Then we will talk about this Governors traits, then the Newland's law of the octave, and this is the Lothar-Meyer volume curves. Then the Mendeleev's the periodic tables, how this Mendeleev uh, designed these periodic tables and how they have classified this the 128 the elements according to their chemicals and physical properties. Then modern periodic table, then the IUPAC, the nomenclatures of the elements, how these uh, elements we can say the naming actually. Then the periodic table in the physical properties, then there are the nuclear charge and the atomic radius and the ionic radius also, ionization, enthalpy. These are the all the physical properties that train we will know about that. And this electron gain enthalpy and this electronegativity and then the periodic tense in these chemical properties and also the periodicity of valence or the oxidation state. That means that there are the several the element they can show different type of the oxidation state and which oxidation state are the stable or not. So about that we will know about and this there are some other second period elements and this chemical reactivity of their elements. So first of all, we know and we are about the modern periodic tables, and this is the modern periodic tables. So in these periodic tables, we can and see that there are the 7 periods and there are the 18 groups. So these elements actually classified and this arranged in this 7 periods and these 8 groups, and they have and this table also classified in 4 blocks. This is the S block, D blocks, and P block, and this A block. But but the point is that how this lots of these elements actually classified these 4 blocks. How this group and how this period actually came, and this S block, D block, and the P block, and the A block, how they came, and how and according to the which properties these elements has been the classified, arranged. That actually is interesting, and for that actually we have to know first of all the history of this periodic table. So first the proposals that came from the Lavoisiers. Then first of all they started the classifications of the element based on the connection. So so this is the actually 90s series. So yeah 99 90s series. So that times there are the no possibility of to check the reactivity. Okay, so to see the metal, so we can see the physical properties. First of all, we can see the physical property. What's the state is there of in the metal? We know there is a 4, the 5, the step is there: the liquid state, solid state, amorphous state, and the gaseous state. So this is the physical properties. So according to these physical properties, right, according to these chemical properties, they actually classified these elements. So end of the result of these studies was our the modern periodic table. So our the modern periodic tables actually based on the chemicals and the physical properties of this element. Okay, so and these elements actually has been arranged according they are the chemical and the physical properties. So that's why the 1789 they classified this element into these metals and the non-metals and the gases and the earth metals. This the came with 1829. He factorized these some elements into the what he called the triads and groups of the 1829. The triad that constitute the element had the comparabilistic chemicals and the order the physical characteristics. What this means that we already know they classified this element according to these physical properties. They have the state. This is the alkali metal. metal, non-metals, and the earth and the gases. So here we can see this is the chlorine, bromine, iodine, and this actually classified as the gaseous state, and this is the lithium, sodium, potassium. This is a metal, and the calcium, strontium, barium. This actually classified as the earth metal. So according to the state, they have the classified is the ninth element into the three traits, and these are actually the atomic mass of their elements. Then the Newland's law of the octaves, 1866, he stated that he suggests that the elements be arranged in the octaves because he noticed when he arranged, when he is going to arrange the elements according to their the atomic mass. Okay, when he arranging the elements in order to the atomic mass, he have to show that uh, the similar and the similar chemical properties and the physical properties the coming after the eighth after the seventh element. That means that the eighth element and the first element has the same the chemical properties and this physical properties. When they were going to arrange this element according to this atomic mass. That's why these notice after the arranging the elements in order to of arrange the atomic mass that's certain. So these are the actually elements where we can see this is the lithium, then the beryllium, boron, carbon, nitrogen, oxygen, fluorine. Okay, then the sodium came. So lithium, when we are going to this lithium to beryllium, and the beryllium to boron, then the carbon, then the nitrogen, then the oxygen, and this fluorine, we can see this atomic number is increasing. Okay, 7 to 9, 9 to 11, 11 to 12, 12 to 14, 14 to 16, and 16 to 19. And 19 to 23, this is the sodium. So this is the eighth element. Okay, so they have actually arranged these eight elements according to this atomic mass. But point is that the physical properties of the lithium and the physical properties of the sodium both are the same. So this is the actually eighth element according based on this lithium. So second eighth element, this is the potassium. Okay. So this eight element also have the same chemical properties and the physical properties uh, like the sodium, like the lithium. That's why here we can see this is the lithium, sodium, and the potassium has been arranged in a same group, and they are called this alkali metal. Okay, so they have the notice this type of the properties, this type of the physical properties and the chemical properties similarity. Then 1869, Lothar Meyer, he has proposed a diagram. Here we can see uh, the when we are going to arrange the elements according to their atomic weight, atomic mass, then the volume also of this element increasing. This is the lithium and the sodium, potassium, rubidium, cesium. So when we are going to arrange this element according to this atomic weight, then the volume also the increasing. Here we can see this is the lithium volume is around this 15. Uh, in the some other the units here it is not mentioned, but when we are going to this sodium, which has the molecular atomic weight is 11, then it has sorry this is a 23, then the volume is increased, it is around this 20 to 23. This is the potassium, this volume is increased to 45. Rubidium, it is the 55. Cesium, it is around the 70 to 73. So this is the diagram we have noticed. Then coming to this Mendeleev. So first of all, we can see that this triads rules and this the octet rules. Here, first of all, the triads rules, they have the classified this element according to this the state. First of all, the gaseous states, metals, non-metals, and the earth. Okay, according to the states, they have the classified. This is the triad. But after that, they have the scene whence we are going to this arrange the element according to this atomic weight or the atomic mass. Atomic weight or the atomic mass with the increasing, then the eight elements will have the same the chemical properties and the physical properties. Okay, so based on that, we can see the lithium, sodium, and the potassium has the same the chemical properties, physical properties, and they are the same the alkali earth metals. So based on that theory, based on that knowledge, the Mendeleev proposed and published a table of this element, which was organized by this increasing the atomic mass also 1869. And the Mendeleev's law is that the physical and the chemical properties of the elements are the periodic function of their the atomic mass. What is that? The statement of this Mendeleev's periodic law, it means that, but it stated that when we are going to arrange the element according to atomic mass, then the physical and the chemical properties are the changing. But when we are coming to the eighth element, then the physical properties and chemical properties are the same to the first element. Similarly, the sixth elements will have the same the chemical and the physical properties similar to the eighth element and similar to the first element. So here we are arranging the element according to the atomic mass, but we are getting the same result of the physical properties and the chemical properties. So that's why Mendeleev says that the physical and the chemical properties of the elements are the periodic function of their atomic mass. That means that according to this atomic mass, when this atomic mass is the changing, then the physical properties and the chemical properties also will be the changing. So according to this atomic mass, they have the arranged this element. According to that, the physical properties and chemical properties also the changing. 1869, he published a table of the element which is actually arranged by this atomic mass. So Mendeleev's periodic tables, after proposing the Mendeleev periodic tables, he discovered the 63 elements which were the actually known. Then in this Mendeleev periodic tables, there are the groups, the eight verticals row. There are the eight verticals row, and the seven groups were the subdivided in the A groups, A subgroups, and the B subgroups. And the eight groups has the ninth elements in the group of the three. That means that there is the subgroups, but no, so there is actually seven groups, but eight numbers groups has the nine element. These nine elements will in the group of the three. That I will show you how actually this he actually has made this table. In the periods, there are the seven horizontal row. So this is actually the Mendeleev, the first periodic tables where we can see there is the periods and there is the group. So first of all, in this Mendeleev's table, first element is the hydrogen. Okay, then coming to the lithium, then the beryllium, then the boron, carbon, nitrogen, oxygen, fluid. And this element actually you can see has been arranged according to this atomic mass. Lithium has the atomic mass is 6.939, beryllium 9.012, boron 10.81, carbon 12.011, nitrogen 14.00, and oxygen 15, and the fluorine 18.99 something. So according to this atomic mass, this element actually has been arranged in this every periods. We can see that. But point is that the properties of this hydrogen and this lithium and the sodium and the potassium, that means that eight elements actually will have the same physical and the chemical properties. After that, we can say also this is the first series, second series. That means that there is the fourth group, fourth periods is there, but in this fourth periods there is the two series. One is the first series, another is the second series. In this first series, we can see this is the potassium, calcium, strontium up to the nickel. It is present. Then the copper to the boron is the present in the second series. Similarly, fifth and the sixth periods also has been divided the two series. But after that, we can see this is the transition series. In that transition series, but in that actually groups, we can see there are the three elements are the present. Three totals, nine elements are the present. Uh, first, this is first actual transition series. They have discovered this iron, cobalt, nickel, ruthenium, rhodium, palladium, ruthenium, rhodium, palladium. Again, they have the returns. But point is that the total 63 elements he has been discovered. But in the modern periodic table, we can see that there are the lots of the modification. There are the lots of the elements has been added. We can know. We are also know that in the modern periodic table, scandium also the tungsten metal. Manganese also the tungsten metal. Vanadium and the tungsten, vanadium, chromium. This also the tungsten metal. But but that time actually they Mendeleev only proposed a table. This is the seven periods and these eight groups the tables. In here, the only the 63 elements were the discovered. So, according to that table, he has there is a some the statement of this Mendeleev has stated is that he declared that an element's atomic weight must be incorrect if it lead to the elements being assigned to the incorrect group. What is mean that? That means that when actually this table has been created according to the atomic mass. And according to atomic mass, this element has been arranged. Okay. So if I put an element in a different group, then the atomic mass of this element will be the wrong. Let's consider here this atomic mass of this boron is 10.81. If I put this boron here instead of this chlorine, then the atomic mass of this boron and atomic mass of this chlorine will be the different. Because that time we know now that atomic mass of the boron is 10 point something and the chlorine is 35. That now we know. But that time actually they didn't know uh, uh, how what is the atomic mass, what's the chemical. Actually, what's the name also is that. Okay, so according to this atomic mass, they have the arrange this element in periodic table. That's why he stated that if the atomic mass is the incorrect, then we can assign this different a wrong elements. Another statement is that he utilized it to predict the three unknown elements or physical properties. Actually, he proposed the some physical properties actually without experiment. Without some experiment, he just proposed the physical properties of the three elements like the barium, indium, and uranium. Okay, so these actually physical properties of these three elements he just proposed. But after discover these elements, he was the correct. He corrected this also the atomic mass of these elements. So that's why there is the some consequence that after the discover of this unknown element between this 1874 and 1885, and the fact that this Mendeleev's predictions for the scandium and the gallium and the germanium were the amazingly close to the actual Steve value, and his table was the generally the accepted. Why it is accepted? Because uh, without know the atomic mass, without know the atomic mass, only know the physical and the chemical properties, he arranged this scandium and the gallium and the germanium. Uh, just arranged according to the physical and the chemical properties. But after discover this atomic value, uh, then it actually showing that these three elements were the placed in the same the exact positions of this table, because when this atomic value has been discovered, they have seen that okay, so the eight elements, the statement of this octet rule, this octet rule, these eight elements should have the similar and the chemical properties. It is the matching. It is the similar. That's why this Mendeleev's periodic tables actually was generally accepted. So there are some advantage of the periodic tables. Mendeleev's the periodic tables is first of all, he proposed the gallium, scandium, and the germanium. These three elements, which that times was not fully discovered of this atomic value. But he introduced all these three element according to only the physical and the chemical properties. This is the actually great achievement of this Mendeleev, and this is actually uh, good advantage of this Mendeleev periodic table. Second advantage is that this is a systematic study of this element. What is mean that systematic study of this element? That means once they want the newcomers actually will know the periodic table, he easily can remember the everyday elements, and he can know and he can find out the a similar chemical and the physical properties trained according to the groups and the table. Okay, let's think about that. We have the lots of the ball. Okay, the 100 balls is there, but if you want to know actually, there are the 100 ball is there, but this ball has the some the physical and the chemical properties. But you have to the arrange this ball about in a way that you can easily remember, you can easily find out that okay, out of these 100 balls, this 10 ball has the this same physical and the chemical properties. Others, the 10 balls also has the other physical and the chemical properties. And there is the strength of this atomic mass and this atomic subvolume. So there is the easy way actually Mendeleev has been the discovered. Okay, to remember this element according to their atomic mass and this physical properties and the chemical properties. So this is the actually systematic study of this element. They he has been he had actually discovered. Second is that correction of this atomic mass. Okay, before this Mendeleev's, we can see this is a platinum and the beryllium and this gold. The atomic mass actually was the wrong. Okay, so after the a few after that of Mendeleev's table, we can see the atomic mass of these three elements actually is correct. So these are the good advantage. This is the three good advantage of this Mendeleev table. But there are the some defects also is there. Okay, that's why actually modal periodic table has been discovered. Every system should have the some default. Then we can uh, discover the new system. More advantage would be there. Okay, so defects should be there or the failures should be present in a system. Similarly, the Mendeleev's a periodic table also had some defects. First of all, the position of the hydrogen. Okay, you can see this is the lithium and the sodium and the potassium. Okay, top of the lithium, top of the sodium, we can see these hydrogens. If you go to the Mendeleev tables, here we can see this hydrogen is there. Okay, lithium, sodium, potassium. These are actually the alkali metal. Okay, so above there, there is the hydrogen is present, but hydrogen is not metal. Hydrogen gas also is a gas. So the physical state is the different. Okay, so we cannot put this hydrogen on top of the lithium. We cannot put this hydrogen top of the sodium. Okay, so this is the mistake of this Mendeleev periodic table. So the mistake is that position of the hydrogen actually is a very very disadvantage of periodic table of this Mendeleev. Then the anomalous pair argon, potassium, cobalt, nickel, beryllium, and this iodine. So, what is that? You can see that potassium and this, what is that? Just give it time. Potassium, argon, cobalt, nickel, beryllium, iodine. Potassium, nickel, argon. What is the argon? Uh, Actually, he is saying that there is the this is a titanium. Hmm. This position actually is not same because these properties, this the manganese, chromium, vanadium, titanium, and this scandium, zinc. These actually are the transition metal. Uh, we can put the hair. So this is the one type of the disadvantage of this periodic table. In the position of the isotope, we can know the hydrogen has the three isotopes. Okay, uh, hydrogen has the three isotopes according to this mass. One, four, three. One hydrogen atom. This is the deuterium and the tellurium. So these three isotopes actually position is not there. Okay, you can see that uh, only there is the hydrogen is there, but where is the isotope? Okay, because the isotope should be the exist now. So we can and we can arrange this isotope of this hydrogen atom, but this is not there. Okay, so this is the one type of the defect. Second is a chemically dissimilar element are the group. Okay, so this is the copper and the sodium. Hmm. You can see that the copper and the sodium. So these two elements are dissimilar according to this. Copper also is the metal and the sodium also is the metal, but the chemical properties are the different. Okay, if you put the sodium in the water, then the fire will be happen. But if you put the copper, then nothing will be happen. Copper oxide also is from the copper plus. But point is that these chemical properties are the not same. Okay, so that's why we cannot put the sodium and this copper in the uh, same the group. So this is the one type of the disadvantage of this periodic table. Second thing is that chemically similar elements are placed in the different positions. If you see, this is the copper and the mercury. Okay, it's a copper. This is the copper and this mercury. Where is the mercury? The mercury is that this is the hafnium, candium. Just give me some time. This is the copper, but this is the mercury. Okay, so copper and the mercury also has the same chemical properties. Okay, but they has been placed in a different groups. So this is also a disadvantage of this uh, Mendeleev's periodic table. Second thing that it is the very interesting that it is very interesting. The Mendeleev's periodic tables was published in 1905 when still no one had an idea of the structure of an element. Okay, but so that time actually atoms is not discovered. What is the atoms? How many protons? How many electrons is there? The structure also, that actually means that the structures of the atom had not any idea of the structure of the atom. So without know the structure of the atoms, without know the how many electrons, how many atoms actually protons is there, without know any information, Mendeleev's was the correct. Okay. So what statement is that the element with the atomic number. So if you see the Mendeleev periodic table again, this is the hydrogen. Okay. So repeat this hydrogen because the positions of this hydrogen is not correct. Okay. So now this lithium, beryllium, boron, carbon, nitrogen, oxygen, fluoride. So Mendeleev has been arranged these seven elements according to this atomic mass. Only he knows the atomic mass. So according to this atomic mass, he arranged this element. But point is that when someone when the atoms, the structures has been discovered, then everybody shows that whatever thinking was there beyond this arrangement of this, but creating this magnetic periodic table, that was actually the correct. Why it was the correct? Because the when we are going to this lithium to beryllium to boron, the carbon, nitrogen, oxygen, fluorine, atomic mass is increasing. That is the correct. But the number of the electron also the increasing the one by one. Okay, so so uh, we can also remember this element series according to the atomic numbers, according to the electrons number also is there. So that's why the Mendeleev's periodic tables is more acceptable than this other. So that's why uh, that's achievement actually for that achievement of this Mendeleev. The elements with this atomic number 101 has been given the name the Mendeleev. Okay, so if you see the uh, uh, modern the periodic tables, which elements actually given the name the Mendeleevs, which has the atomic number 101. This is actually according to this Mendeleev. And the perpetuating this Mendeleev's legacy. So in recognition of the pioneering the role of the great Russian chemist who was the first to use the periodic system to predict these chemical properties of the undiscovered these elements, and a principle which has been the key to the discovery of nearly all the transient element proposed the Americans, the scientist Galen T. Seaborg, the one who discovered this element. Okay, so that time actually this elements was not discovered, but after discovering this element, which the atomic mass is 101, and this 101 elements, the names has been given according for this legacy of this Mendeleev. So this is the Mendeleev. So this is actually achievement of this Mendeleev. So actually Mendeleev, without know the atomic structures of this element, well, only based on these chemical and physical properties, he arranged this element according to this atomic number. That's it. So when he arranged these atomic numbers, uh, according to this atomic number, he when he arranged these elements, but when we know this atomic structure, we already these elements actually has been the arranged according to this atomic number, also according to this the electrons. So this was the great achievement of this Mendeleev. That's why this 101 atomic number based metal, the name actually has been given by this Mendeleev and the Mendeleev. So here I will stop this class and um, so if I summarize this class that so this is the some the basic idea of that periodic tables, how this actually modern periodic table has been the created. Now, before the Mendeleev, there are the lots of theories there, and there are the octaves rules and triads is there, but these are not the actually acceptable because there are the some faults. But when the Mendeleev that came, then he discovered the 63 the elements and he arranged these elements. greatly and understand also the elements is very easily, and the students actually easily can that remember this element. So this is a great achievement. So this is actually basic the idea of this periodic tables, and this is also the history of this periodic table. Uh, so based on that, we will continue the next class where we can see the modern periodic tables. Okay. So this how this modern periodic tables has been classified in the three blocks S, P, D, F, and which elements is there, and how many groups and how many periods are there. Then we will go forward to the chemicals and the physical properties of this element. So thank you, students. So here I am going to stop the first class. So this is okay. Thank you.